6.1 through 6.3 continues from the other day. All right, moving on. Let's see what we have. Biology scientists, quiet please, studied the weights of alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown below. After how many months did the alligators weigh the same amount? So they're giving me the information in words this time, and we need to write the equation. So we have weight and time instead of x and y, but you can treat them just like that's the x. Oops, sorry, that's not the x, that's the y. Weight is based on time, so T is our x and W is our y. Add that into your notes, please. So the initial weight for alligator 1 was 4 pounds, and the growth rate was 1.5 per month. So that is our slope, and our initial weight is our y-intercept. So we will have W equals, what's the slope? The per month one. Is that 1.5? T plus the initial amount. How much did he weigh at first? 4. Good. So there's our first equation. Ian, stay with me. Thank you. And our second equation will be the weight is equal to what? Anybody see it? What's the weight per month? 1. So 1T plus how much did he weigh at the beginning? 6. All right, so we need to graph these two. I will tell you, fractions and slopes are much easier than decimals. So I want you to write that 1.5 as 3 over 2, T plus 4, because that's far easier to see rise over rise. So let's get our graph. We've got this and this. So this is W and this is T. All right, so we start with our y-intercept. That's at 4. We go up 4. 1, 2, 3, 4. I'm going to put that here. And my slope is up how many over how many? Very nice. 1, 2, 3 over 1, 2. If you left it as 1.5, you could go up 1.5 over 1, but 3 halves is easier to work with than 1.5. So now we'll draw our line through here. There's that one. You with me? Got it already? No. Do you have the second one? Thank you. All right. And then our other equation is 1p plus 6. Where do I begin? Yep, that's 4, 5, 6. This color. So I start up here. And my slope?
1 over 1.
1 over 1. Up 1 over 1. Or down 1 and to the left. And we'll draw our line in here. And then our solution, where they overlap. Right there. So we need graph paper to make a better approximation. It looks like maybe what? 4, 8 maybe? Ish. Okay, as our approximation. So that would mean after 4 months, they would weigh the same. All right. So here you need to get these into your notes. There's some terms that we deal with when we talk about systems. We say whether it's consistent or inconsistent, independent or dependent. So consistent, what I want you to have in your notes, means that there is a solution. There is some solution. Inconsistent means there is no solution. Independent means there's exactly one solution. And dependent means that there are many, or infinite solutions. So when we classify systems, we pick one of these two, and we pick one of these two. Okay, so let's go back over here. We have to say whether each system is consistent or inconsistent, independent or dependent. So, is there a solution to this number 1? There is a solution. So we would say it is consistent. And are there many intersections or just one? Just one. So it's independent. That first one, when they cross, ends up being consistent and independent. Number 2, sketch a couple of parallel lines in your notes. So, with parallel lines, do they ever cross?
No.
No. So, is there a solution at all?
No.
So, what do we call this one? Inconsistent. Yep. And then finally, number 3, we have 2 lines here, but they happen to completely overlap. Lines completely overlap. There you go. And how do the first two? Consistent because there's an infinite number of solutions. They overlap everywhere. So it is consistent. And what's the second part? Independent or dependent? Dependent, because there's many solutions. Good. All right. Okay, so we just looked at pictures that showed when we had infinite solutions, no solution, and one solution. What does it look like if there are infinite solutions?
Overlap.
They overlap completely. It looks like one line. Okay? What if it's no solution?
It's only one line. More than that.
Parallel. Yeah, it's still a system, so there has to be more than one line. But if there is no solution, then they are parallel. And never touch. And then one solution?
It's where the 2 lines crossing.
Yeah, they just cross one.
What if there's no line?
For a system, there has to be 2 or more. So this one would look something like that. Okay? A little sketch for each. All right. Are we good? No, not yet. Okay. Thank you for saying so. All right. So now, we solved this problem before by graphing. And what I want to do now is solve it by substitution. So you remember that pre-assessment I said, do you remember how to solve a system using substitution? So let's write down what substitution means. Add this to your notes, please. We substitute, or plug in, from one equation to the other. notes to yourself, solve for one variable in one equation. Which means get x or y by itself. And then we plug that into the second equation. All right? And then we solve for the variable. Okay, so let's look at this first equation right here. Let's get x or y by itself. Well, tell me something. Is x or y already by itself? What's by itself? The y is already alone, correct? Yep. So step one is already done. Y equals x plus 2. We don't need to move anything. The y is by itself. All right? So now, if y is equal to x plus 2, in the second equation, instead of writing y, I can write what y is equal to. What is it equal to? X plus 2. So we can rewrite the second equation, replacing y with x plus 2 is equal to 3x minus 2. And then we just have a simple equation to solve with one unknown. So now it's like candy, the fun part. Ian, stop it, because we need this. I need to do this, because I'm killing you here in my room. So, how do we solve this guy? We want the x's on one side, and the numbers on the other. Sure, I can subtract 2 from both sides, and that leaves me with x equals what? 3x. Hold on, 3x minus 4, right? Those two combined. All right, and now what? I need to get my x's on the left then. How do I move this guy over? Not the bottom. Hold on. It's being, not multiplied, it's being added or subtracted, added here. This is negative 4 plus 3x, so we want to subtract the 3x to the other side.
Oh, okay.
Okay? So this is 1x minus 3x, giving me, what's 1 minus 3? Good. Negative 2x equals, these cancel. That's those cancel. Equals negative 4. Now we're ready to divide by the negative 2. And we get x equals 2. Put a cloud or a box around that. That's part of our answer. We need a y to go with that. Where can I get that? If x equals 2, then I can get y by plugging in 2 for x. So y equals x plus 2. We plug this guy right in there. So y equals 2 plus 2, giving us 4. And our solution is the point 2, 4. All right, so we substitute from one equation into the other. Are we okay with that? Do you remember seeing that? Yes? Yes? Do you guys remember it? Okay. All right, so finally we have to do the same problem, but this time with elimination. All right. Elimination is where we eliminate one of the variables. By adding or subtracting the two equations. So on this one, the first thing we have to do is line up all the variables in the same place. Y equals x plus 2, and y equals 3x minus 2. Are they all lined up? Y's over y's, x's over x's, numbers over numbers. We're okay? Check. All right. So if if I were right now to add these two equations, would any of the variables go away? If I add y plus y, I get 2y. If I add 1x plus 3x, I get 4x. The 2's would go away, but it doesn't get rid of our variable. So we need to multiply by something so that they will cancel each other out. Multiply the equation by a number so they will cancel out. All right, so what can I multiply the second equation by so that when I add them together, the y's go away? I want to get y plus negative y so that they go to 0. What do I multiply the second equation by to get negative y? I can multiply the whole thing by negative 1. So if I do that, what do I have now? Negative y is equal to, help me, negative 1 times this. Look up there. Negative 3x, thank you. And negative 1 times negative 2? Positive 2. So I've changed the look of the second equation. Now I'll rewrite our first one. Y equals x plus 2. Now when I add them, negative y plus y, what happens? That's 0, right? They cancel out. Negative 3x plus x. What's negative 3 plus 1? Negative 3 plus 1. I know I'm telling you, we're almost done. Negative 3, thank you. Plus 1 is negative 2. So we have negative 2x. What is 2 plus 2? 4. So now we have to solve this equation. We will subtract our 4. And I have negative 4 equals negative 2x. Divide by the negative 2 like we did before. And we get x equals 2. Just like we did in the last equation. The last problem. And then how do I get my y? I know, almost. Plug back in. Y equals x plus 2. We plug that 2 in for x. Y equals 2 plus 2. And we have y equals 4. So we've gotten the same answer 2 different ways. Oh, sorry. So, now, you're going to get your packets